Hello all. In this video we'll be learning about active reinforcement learning. So what is active reinforcement learning? Unlike passive reinforcement learning, in active reinforcement learning we are not bound by a policy by and we need to select our own actions. So it means that the agent needs to learn an optimal policy on the go. The fundamental trade-off the agent needs to face is that of exploration and exploitation. An example for active reinforcement learning is Q-learning. So now we'll learn what is Q-learning. In Q-learning, the agent learns an active function Q which gives the utility of taking a given action in a particular state. So the Q-learning does not require a transition model and hence it is said to be a model free method. So consider an example. Here there are 5 rooms. The rooms are numbered as 0, 1, 2, 3 and 4. To move from one room to another, there is a door or you consider as a gap. And this 5 represents outside of the building. So to move to outside of the building, we have 2 parts. One is from room number 1, you can move outside of the building, that is to reach 5. And another one way is we have is from 4, we can move outside of the building, which is also represented as 5. So with 2 ways we can move outside of the building, that is from 1 to 5 as well as from 4 to 5. So this building can be represented in a form of graph. So totally we have 5 rooms and another one is the outside one. The goal is to move from any one room of the building to the outside of the building. Okay. So now we are representing it is in the form of a graph. So this is the graphical representation. So we have nodes. Each and every rooms are represented in the form of nodes 0, 1, 2, 3, 4 and 5. 5 is represented as goal because we need to reach the goal. That is, we need to move from the building to the outside of the building. Consider we are in room 2. So from here, how to move outside of the building? We can move to 3, 3 to 4 and we can move out. Otherwise, the another way is 2 to 3, 3 to 1 and from 1 to 5. So here also you can see the 2 ways from 2 to 3, 3 to 4 and from 4 to 5. Another way is from 2 to 3, 3 to 1 and 1 to 5. So here you can see the path. From 2 to 3 you can move. Similarly from 3 to 2 you can move. So here you have 2 arrows. One is from 2 to 3 and another one is from 3 to 2. Okay. So similarly all the arrows are represented. So now here we are giving certain values. So what kind of values we are representing here? Consider the person is in room number 2. He needs to move to outside of the building, that is 5. So here certain rewards are given. So if the person is moving inside the building, then the reward given will be 0. And if the person is moving towards or outside of the building, then the reward will be 100. So based on it, we are planning the reward in the graph. So if the person is moving from 2 to 3, then the reward will be 0. Similarly from 3 to 2, the reward will be 0. So similarly anywhere here inside the building, the movement inside the building, the reward will be given as 0. You can see anywhere here. And then if the person is moving from 1 to 5, then the reward will be 100. And 4 to 5, then the reward will be 100. So 1 to 5, the reward is 100 and 4 to 5, the reward is 100. The person is moving in 5 itself, that is outside the building itself, then the reward will be 100. Elsewhere, the rewards are 0. So that is given in this graph. Now, with this example, we learn what is Q-learning. So as we have discussed, it's represented in the form of states. Okay, there are 6 states that is 0 to 5, and then action. Okay, so when we do a move, we'll be getting actions and the values are also given. And here we represent the state action in the form of a table, state action table or reward table. So in this, the state is represented here and the action against the action. What are all the actions? Okay. So for example, from 0 to 0, you don't have a move here. In this graph, you don't have a move. So the agent actually won't does the move. So in such cases, you can see the reward as -1. Okay, similarly from 0 to 1, we don't have a move. In such case, this reward matrix will be -1. The value will be -1 in the reward matrix. So for example, we have from 0 to 4, we have a move with reward 0. That is mentioned in this reward table or reward matrix. Then consider from 1. From 1 to 3, we have a move with reward 0, and 1 to 5, we have a move with reward 10. So that is represented here. Similarly, from state 2, we have only one move to 3 with reward 0. So that is represented here, and the other values are represented as -1. Then from state 3, there are 3 moves. It can move to 1, 2, 4. So whatever move it is, the rewards are 0. So from 3, it can move to 1, 2 as well as 4. All the reward values are 0. Then from 4, it can move to 0. It can move to 3. Similarly, it can move to 5. When it moves to 5, the reward value is 100, and other cases the reward values are 0. So when the agent moves from 4 to 5, the reward is 100, and other cases the reward is 0, and the remaining cases the reward values are -1. And similarly from 5, it can move to 1. From 5, the agent can move to 4, and from 5, the agent stays in the outside of the building itself. That is, you have a loop here. Okay. So in this case, the reward is 100, and other cases the rewards are 0. And remaining cases, if there is no move at all, then those cases are represented as -1. Okay. So this is how we fill up the reward table or reward matrix. After filling the reward matrix, we'll do certain calculations. So before going into calculations, we learn the Q-learning algorithm. So the Q-learning algorithm goes this way. For each state and the action, initialize the table entry Q cap S comma A to 0. So first what we are going to do is, we will be finding the Q matrix of S comma A. S is the state and A is the action, and we initialize it to 0. And then what we need to do is, we need to observe the current state S. From the current state S, we need to do certain things. So what things we need to do? Select an action A and execute it. We need to select a particular action and we need to execute it. Okay, and then we'll be receiving, on executing the action, we'll be receiving an immediate reward R. Then after receiving the reward R, observe the new states S dash. After observing the new state S dash, update the table entry. Okay, your Q table entry, we need to update it. How to update it? Q cap of S comma A is equal to the reward whatever you got plus gamma, that is the discount factor, and maximum of Q of S dash comma A dash. So what are all the next actions? Based on that, you need to select the maximum value and we need to apply it. Then from S, we will be moving to S dash. Okay, so this is the algorithm. We'll apply this algorithm for the example whatever we have seen in the previous slide. So now we fix the learning rate gamma as 0.8 and the initial room is 1, and we initialize the Q matrix. Already we have calculated this reward matrix. This is the reward matrix we have already calculated, and this is the Q matrix. Initialize the Q matrix with values 0. So we initialize this Q matrix with value 0. Now what we will be doing is, first we are in the state 1. Consider we are in state 1. Okay. It means that the agent is in state 1. So where we have the state 1, here we have the state 1. Now look into the state 1 entries. So from state 1 you can move to state 3 as well as state 5. So in this diagram also it shows that from state 1 you can move to state 3 as well as to state 5. Okay, so that is given here. Now we'll be picking up a random state. From here we can move to 3 or otherwise we can move to 5. So in this case I am picking up 5. Okay, randomly, just randomly we are picking. So we are picking from 1 to 5 we are moving. So now we need to calculate what is the Q value for 1 to 5. So to calculate this, what we will be doing? So now 5 will be the next state, right? We are choosing this, so 5 will be the next state. We consider the S dash as 5. Okay, S dash as 5. Now we need to move to the state 5. So when we move to the state 5, we will be looking into this entry. So this entry we will be looking. So when we look at this entry, here from 5 we can move to state 1. We can move to state 4 as well as we can move to state 5. Okay, so from 5 we can move to state 1, we can move to state 4 as well as we can move to state 5. Now we will be calculating the Q value. So how to calculate the Q value? In algorithm it's fully represented in the mathematical notation. So we have written here in the English notation which is easily understandable. So it's Q of state comma action is equal to the reward value for the particular state comma action plus the gamma value into maximum of Q comma next state for all the actions. Okay, so we are going to calculate it. So how to calculate it? Q of state comma action. So for which particular state we are going to look into? So Q of 1 comma 5. So we are going to find this value Q of 1 comma 5 we are going to find. To find 1 comma 5, we need to find what is the reward value for 1 comma 5. So what is the reward value for 1 comma 5? The reward value for 1 comma 5 is 100. So the reward value for 1 comma 5 is 100. And then gamma value, already we have fixed the gamma value as 0.8. Okay, then we need to find the maximum of Q next state of all actions. So what is the next state? From 1 we are moving to 5. So 5 is the next state, and what all actions it can do? It can, from 5 it can go to 1, it can go to 4 as well as it can go to 5. So it can go to 1, it can go to 4 and it can go to 5. So Q of 5 comma 1, Q of 5 comma 4 and Q of 5 comma 5. So what is Q of 5 comma 1? It is in Q of 5 comma 1 is 0. What is Q of 5 comma 4? It is 0. And what is Q of 5 comma 5? It is 0. So what is maximum of 0, 0, 0? It is 0. So we will get 100. 100 is the reward of 1 comma 5 which is 100 plus 0.8, that is the gamma value, into 0. So you understood how we get this 0. So when you simplify this, we will get 100. So now we will be placing 100 in where we will be placing Q of 1 comma 5. So this is the Q matrix. In Q matrix with 1 comma 5 we will be placing this Q of 1 comma 100. Okay, so this is what we get. Okay, now 5 becomes the current state. So now 5 is the goal state. Okay, 5 becomes the current state and 5 is the goal state. So we have reached it. So that's fine. So where we have started? We have started from 1. From 1 we have reached 5. So for 1 we have two parts. One is 5 and another one is 3. So now we will explore 3. So how to explore 3? So when we consider 3, we need to, if from 1, what is the next state? The next state is 3. So where we need to consider? So the next state is 3. So here in third row we need to check it out. So when we check it, the third row we have From 3, it can move to 1, it can move to 2, as well as it can move to 4. Consider we are in state 1 and look into the state 1. So when we look at the state 1, there are two possible states. One is 3 and 5. Already we have seen 5. Now we need to compute Q. So when we compute Q, we'll use the same formula, and now when we compute Q, we'll get 3, 1. So what is for 3, 1? The reward for 3, 1 is 0. Okay, so it is 0. And then 0.8, which is the discount factor 0.8. And then maximum of 0, 100. So what is it? What it is? Maximum of 0 and 100. So when we calculate it, we'll get us 80. So we found the value as 80 here. Similarly, you can do for all other calculations, and then we'll get the Q matrix this way. This Q matrix can be converted into the graph. So consider, for example, 2 is the initial position. From 2, how to find out? From 2, you take the highest score. Which is having the highest score? 3 is having the highest score with 64. From 2, there is a path to 3 with the reward 64. Now, from 3, you check out here. From 3, you have certain values. So, which is having the highest value? 1 as well as 4. You can select any path. Both are having the same value. 1 as well as 4 are having the same value. You can select any path, 1 or 4. So, from 3, if I select 1, then you check out this one row. Okay. So, when we check out this one row, which is having the highest value 5. So, automatically the path leads to the goal state. For example, if you are in 3 and you are selecting 4. So, now if it is a 4, you choose 4. So, 4, in 4 also you check for the highest value which leads to the goal state from 5. From 4 it leads to the goal state from 5. From 5, again you check for the highest value. Highest value is 100, which is for 5. So, in 5, you will be looping in 5 itself. So, you can convert a Q matrix to the graph by selecting the highest value in the Q matrix. This is how the Q learning works. Thank you.